So here it is told that a body of mass 8 kg and another of mass 2 kg are moving with equal kinetic energy. The ratio of their respective momentum will be. So we know that kinetic energy equal to p square by 2m. So they have equal kinetic energy. That means I can say ke1 equal to ke2. It means I can say p1 square by 2m1 that is equal to p2 square by 2m2. Therefore, p1 square by p2 square that will be equal to m1 by m2. So the ratio of their respective momentum we have to find means p1 is to p2 has been asked. So p1 square by p2 square that will be equal to m1 that is 8 kg by 2 kg. That is 4 by 1. So therefore p1 by p2 that will be equal to 2 by 1. So it means p1 is to p2 is 2 is to 1. So option B is the correct answer. Then here it is told that two billiard balls of mass 0.05 kg each uh, moving in opposite directions. So they are having same mass m, where m is equal to 0.05 kg. So they are moving in opposite direction with same velocity, initial velocity with 10 meter per second, collide and rebound with the same speed. So after collision, they will again rebound with the same speed. If the time duration of contact is 0.005 seconds, then what is the force exerted on the ball due to each other? So the impact force during collision has been asked. So here we can say m1u1 plus m2u2 that will be equal to m1v1 plus m2v2. Since why they are rebounding with the same speed, so v will be equal to u only. So therefore the force exerted that will be equal to 2 mu by t. 2 mu by t. So 2 into 0.05 into u, that is 10 by t. That is 0.005 seconds. So this much Newton. So if we shift the point, then we will get 2 into 50 into 10 by 5. So 5 tens are 50. So 200 Newton. 200 Newton is the force exerted by the ball due to each other during the collision. So option B is the correct answer. Then it is told two bodies A and B of masses 5 kg and 8 kg are moving such that the momentum of body B is twice as the momentum of body A, and their masses of A and B are 5 kg and 8 kg. So MA is 5 kg, MB is 8 kg. And the ratio of their kinetic energies will be. So you have to find the ratio of the kinetic energies. Means KEA is to KEB. That we have to find out. Now KEA by KEB will be equal to, we know that kinetic energy is P square by 2m. So this will be equal to PA square by M2MA is to PB square by 2MB. It means that will be PA square by PB square into MB by MA. So from here we can see that PA by PB, it will be equal to 1 by 2. This is 1 by 2 whole square into MP, that is 8, and MA, that is 5. This will be 8 by 4 into 5. So 4 2 is 8, that is 2 by 5. It means the ratio, the required ratio will be 2:5. Option B is the correct answer. It is told that a body of mass m at rest explodes into 3 pieces in the ratio of masses 1:1:2. Two smaller pieces fly off perpendicular to each other with velocities 30 meter per second and 40 meter per second respectively. The velocity of the third piece will be. So there is a mass m. It is at rest only. U is 0. So it will explode into 3 parts. So let's say m will be equal to 4m. Let's say suppose. So therefore, the two smaller pieces fly off perpendicular to each other. We can say one is flying off, let's say like this, 30 meter per second. This is mass m, and another mass m where is flying off perpendicular to it, 90 degree. This is 40 meter per second. So the third mass, which is 2m, so it should fly off with a velocity v, the opposite direction, such that the net final momentum of the system should be 0 only, since initially the system was at rest. So the center of mass should remain at rest only after the explosion. So after explosion also, the center of mass will remain, the center of mass of the system will remain at rest. So I can say the net final momentum of the system, that should be equal to 0. So simply it means, you can say, let's say this is theta, then this will be 90 minus theta. So this is 30 cos theta. This is 30 sin theta. And this is what, this will be theta. So this will be 40 cos theta. This will be 40 sin theta. So from here we can say that the net momentum along the y direction, that should be 0, and the net momentum of the system along x-axis, that also should be 0 only. Py should be 0, px should be 0. So py is 0, it means 30 sin theta, that should be equal to 40 cos theta. So therefore tan theta will be equal to 4 by 3. Tan theta equal to 4 by 3. So therefore theta is 53 degree. It means that sin theta is 4 by 5 and cos theta is 3 by 5. So now therefore V will be equal, so, or I can say, sorry, 30 cos theta, but m, this will be into m. Mass is m. So m into 30 sin theta should be equal to m into 40 cos theta. So m will cancel. Then we will get theta is 53 degree only. And here also this will be m 2m into v, 2mv. It means the net momentum along the y-axis, along the x-axis should be 0. So it means 2mv, that should be equal to m into 30 cos theta plus 40 sin theta. So therefore m will cancel. So therefore I can say 2v, that is equal to 30 into cos theta is 3 by 5. 40 into sin theta, that is 4 by 5. This will be 5 6 are 30, 5 8 are 40. So 2v will be equal to 3 6 are 18 plus 4 8 are 32. So v will be equal to 9 plus 16. So v is 25 meter per second. So the velocity of the third piece will be 25 meter per second. So option B is the correct answer. Here it is told two blocks of masses 10 kg and 30 kg are placed on the same straight line with coordinates 0, 0 centimeter and x, 0 centimeter respectively. Two blocks are there. Blocks, one of mass 10 kg and one of mass 30 kg, are placed on the same straight line. They're placed on the same straight line with coordinates. So this one is placed at 0, 0 centimeter and 30 kg. This is placed at x, 0 centimeter. So their separation is x centimeter. The block of 10 kg is moved on the same line through a distance of 6 centimeter towards the other block. The distance through which the block of 30 kg must be moved to keep the position of center of mass of the system unchanged. So it is that XCOM, the x coordinate of the center of mass of the system, that will be equal to 10 into means simply it is, we know that m1 x1 plus m2 x2 by m2 x2 by m1 plus m2. So here it is told the change in the, so the position of center of mass of the system should remain unchanged. So it means delta XCM that should be equal to 0. It means change in the position of center of mass should be 0. So it means what? M1 delta x1 plus M2 delta x2, that should be equal to 0. So now delta x2 has been asked. So then here it is told if delta x1 that is equal to, so 10 kg is moved 6 centimeter towards the right towards the 30 kg block. So it means that it will be now placed at 6, 0. So therefore delta x1 that is 6 centimeter. Then we have to find out delta x2. We have to find out. And M1 has been told M1 is 10 kg and M1 is 10 kg and M2 is 30 kg. So therefore I can say delta x2 that will be equal to minus of M1 by M2 into delta x1. So that will be minus of M1 that is 10 kg by 30 kg into delta x, that is 6 centimeters. 3 to just 6. So minus 2 centimeter. So it means that the 30 kg block should be moved by 2 centimeter towards the 10 kg block. It means it should be now placed at x minus 2 centimeter. 2 centimeter towards the 10 kg block. So option C is the correct answer. Then it is told what percentage of kinetic energy of a moving particle is transferred to a stationary particle when it strikes the stationary stationary particle of 5 times its mass. Assume the collision to be head-on elastic collision. So it is a head-on elastic collision. So it is a stationary block U2 that is 0. So the stationary object, it is at rest. Its mass is suppose so m2 that is equal to 5m, and where this particle or an object is moving with a velocity, initial velocity u1 equal to u, suppose, and then its mass m1 is m, then how much percentage of its kinetic energy will be transferred to the stationary particle if there is head-on elastic collision? So first thing is that the kinetic energy of the system is conserved since it is elastic collision, and also the net linear momentum of the system, that is also conserved. So here we can say m1 u1 plus m2 u2, that is equal to m1 v1 plus m2 v2. It means that after collision, let's say the smaller mass moves with a velocity v1, and the stationary object, the stationary particle, moves with a velocity v2, suppose. Then we have to find out how much percentage of kinetic energy of this moving particle is transferred to the stationary object. So we can say m1 means m into u plus m2, that is 5m into 0, that is equal to m1 m into v1 plus 5m into v2. So m we can cancel, so therefore u will be equal to v1 plus 5v2. This we got one equation. And then kinetic energy is conserved, it means half m. So it means the final kinetic energy of the system, that is equal to the initial kinetic energy of the system. Or we can also use the formula for coefficient of restitution, which is E, that is equal to V2 minus V1, V2 minus V1 by U1 minus U2, where the coefficient of restitution is 1 only, since it is a head-on elastic collision. So therefore, you can say that V2 minus V1 by U2, U1 is U minus 0, that is equal to 1. Therefore, V2 minus V1, that is equal to U. V2 minus V1 equal to U. So V2, I can say that will be equal to U plus V1. So U equal to V1 plus, it is told 5V2, so 5 into U plus V1. So you can say 5V1 plus V1, that is 6V1, that is equal to U minus 5U. It means 6V1, that is equal to minus 4U. Means V1 will be minus 4U by 6, that is 2 to the 4 to the 6. So V1 will be equal to minus 2U by 3. So therefore V2, that will be equal to U plus U minus 2U by 3, that is equal to U by 3. So therefore the percentage of the initial kinetic energy of the moving particle that is transferred to the stationary particle is the kinetic energy of the initial kinetic energy of the percentage of initial kinetic energy of the moving particle that is transferred, so that will be equal to the final kinetic energy of the second object of the stationary particle divided by the initial kinetic energy of the first particle into 100%. So the final kinetic energy of the stationary particle or the second particle, that will be equal to half into 5m into v2 square. Means it will be half into m2 into v2 square by half into m1 into u1 square into 100%. So half will cancel. So then m2 that is 5m into v2, that is u by 3 whole square, divided by m1, that is m into u1 that is u square into 100%. So this will be equal to mu square will cancel. So 5 by 9 into 100%. So that is 500 by 9%. So which will be equal to approximately, which is 9 5s are 45, 50, 9s are 45, 50. So it will be 55.56 percent approximately. So 55.6% you can say. So option C is the correct answer. Then here it is told an object is thrown vertically upwards. Object is thrown vertically upwards with an initial velocity u. At its maximum height, which of the following quantity becomes 0? That we have to find. An object is thrown vertically upwards. At its maximum height. So when it will reach the maximum height, that is h max, then its final velocity will be 0. So which of the following quantity becomes 0? That we have to find. So the at its maximum height, the final velocity will be 0. So final momentum also will be m into v, that will be 0 only. And the potential energy is not 0 since it will be equal to mgh. And h, we can say h is equal to v square minus u square by 2a, that is 2 into minus g. So h is equal to u square by 2g. So therefore mgh, you can also say mg into u square by 2g. So it is equal to half mu square, which is the initial kinetic energy also. So the acceleration also is not 0 since why the acceleration due to gravity g is always acting. And the force is also not 0 since why for any object the weight, its own weight, which is mg, that will always act vertically downwards. So only the momentum will be 0 when it will reach the maximum height. So option A is the correct answer. Here it is told the distance of center of mass from end A of a one-dimensional rod AB. There is a one-dimensional rod AB is having the di distance of the center of mass from the end A. From the end A, the center of mass is at x naught, suppose. So this is at x, and A is suppose at x equal to 0 and B is at x equal to L, suppose. Having mass density, so it's mass density which is rho, which is equal to dm by dx, which is rho naught 1 minus x square by L square into kg per meter, which is also called as mu, which is the linear mass density. So actually they are saying it is rho only. And length L in meter, length L in meter is 3L by alpha. So here x naught is told, x naught, the xcm I can say. Which is this alpha we have to find, where x is the distance from end A. X is the distance from end A. So here, if we take a small mass dm, so here the x coordinate of the center of mass of this one-dimensional rod, that will be equal to integral x dm by integral dm. Integral x dm by integral dm, and x will go from 0 to L, obviously 0 to L. So now therefore integral dm that we have to find, which is the total mass of the rod. The total mass of the rod is integral dm from 0 to L. So it should be integral 0 to L dm, that will be equal to rho into dx. So dm that will be equal to rho naught into 1 minus x square by L square into dx. So this will be rho naught into 1 minus x square by L square into dx. So this will be integral rho naught dx from 0 to L minus rho naught by L square integral x square dx from 0 to L. So this will be equal to rho naught L minus rho naught by L square into x cube by 3, is L cube by 3 square x cube by 3. Okay, so this will be rho naught L into, no, minus rho naught L by 3, which is equal to 2 rho naught L by 3. Rho naught L into 1 minus 1 by 3, that is 2 by 3. So the mass of the rod is 2 rho naught L by 3. Then integral x dm we have to find, 0 to L integral x dm. So this will be 0 to L integral x into rho dx. dm, that is rho naught into 1 minus x square by L square into dx. So this will be equal to rho naught integral x dx from 0 to L minus rho naught into, this will be x cube by L square dx from 0 to L. So this will be equal to rho naught into L square by 2, since the integral x dx is x square by 2, minus rho naught by L square into this x cube dx, that will be equal to x power 4 by 4. So this will be L square. This will be equal to rho naught L square half, rho naught L square into half minus 1 by 4 rho naught L square by 4 So therefore the x coordinate of the center of mass of the rod, that will be equal to integral x dm, that will be rho naught L square by 4 by 2 rho naught L by 3. So this will be 3 by 2 into 1 by 4 into rho naught L square by rho naught L. So rho naught will cancel, L will cancel. So this will be 3L by 8 equal to 3L by 8. So which is given as 3L by alpha, 3L by alpha. So therefore alpha is equal to 8. So the value of alpha is 8. Then here it is told 3 identical spheres, each of mass m. 3 identical spheres, each of mass m, are placed at the corners of a right-angled triangle. Three identical spheres, each of mass m, are placed at the corners of a right-angled triangle with mutually perpendicular sides with mutually perpendicular sides equal to 3 meter each. So with mutually perpendicular sides equal to 3 meter each. So each perpendicular side is 3 meter each. Taking point of intersection of mutually perpendicular sides as the origin. So it means this is the origin. This point is the origin 0, 0. Then the magnitude of position vector of center of mass of the system will be root x meter. The value of x is. So their masses are m. So since they are uniform spheres, so their center of masses will lie exactly at their geometrical center. So this will lie at 0, 3. This center of mass will lie at 0, 3, 0. So the x coordinate of the center of mass of the system, that will be equal to m1 x1 plus m2 x2 by plus m3 x3 by m1 plus m2 plus m3. So this will be m, all masses are same, which are m only. So m into x1, that is 0, plus m into x2, that is 0 also, plus m3, that is m into x3, that is 3 by 3m. So m will cancel. So that is 3m by 3m, that is 1 meter. 1 meter. And y coordinate of the center of mass. So here the position vector of the center of mass, that is RCOM vector, if it is XCOM comma XCOM I cap plus YCOM J cap. So we have to find the magnitude of the position vector of the center of mass of the system, and if that is equal to root x meters, then the value of x we have to find out. So y coordinate of the center of mass, similarly that will be m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3, that is 3m. So this will be m into y1, that is 0, plus m2, that is m into y2, that is 3, plus m3 m into y3, that is 0 by 3m. So it will be also 3m by 3m, that is 1 meter. So therefore the position vector of the center of mass of the system, that is 1 I cap plus 1 j cap meters. So I cap plus j cap. So therefore the magnitude of the RCM, that will be equal to square root of 1 square plus 1 square, that is equal to root 2 meters. So therefore the value of x is 2. So the answer is 2. Then here it is told a man of 60 kg is running on the road. A man of 60 kg is running on the road, and suddenly he is running on the road and suddenly jumps into a stationary trolley car. He will jump into a stationary trolley car. It is stationary. So he is moving with some initial velocity u, and he jumps, and this initial velocity u2 of the trolley car, that is 0, u1 equal to u. Its mass is m2, m1 is 60 kg, m2 is mass of the trolley car, that is 120 kg. Then the trolley car starts moving with velocity 2 meter per second. So here it is told that after he gets onto the trolley car, then the trolley car along with him will move with a velocity 2 meter per second. This is v. The velocity of the running man was how much when he jumps into the car. So u has been asked. So here we can apply conservation of momentum of the system. So that will be equal to m1 plus m2 into v. That will be equal to m1 u1 plus m2 u2. Since why the final velocity of both man and the car is v only. So m1 is 60, m2 is 120 into v. That will be equal to m1, that is 60 into v u1 that is u plus m2 that is 120 into 0. So therefore v will be equal to 60. So u will be equal to 60 plus 120, that is 180 by 60 into v. V is 2. So 6 3 is 18, 3 2 is 6 meter per second. So it means the initial velocity of the running man was 6 meter per second. So 6 is the answer. Then here it is told batsman hits back a ball of mass 0.4 kg. It is 0.4 kg straight in the direction of the bowler without changing its initial speed. So it will come with initial speed which is 15 meter per second, and he hits it with the bat, and the ball will return back with the same speed u, that is 15 meter per second. The impulse imparted to the ball is, so therefore the impulse imparted, that will be equal to the change in linear momentum of the ball. So that will be equal to delta p, that is mu minus of minus mu. If I take the direction towards left as positive and the direction towards right as negative. So therefore that will be equal to 2 mu. So 2 into m, that is 0.4 into u, that is 15. 15 to the 30, 3 into 4, that is 12 Newton second. So 12 is the answer. Then here it is told a body of mass m, moving with a initial velocity v naught collides elastically with a mass small m which is kept at rest. So here initial velocity u1 is v naught, u2 is 0 since it is kept at rest. After the collision, the two masses move at angles theta 1 and theta 2 with respect to each other. So theta 1 and theta 2 with respect to the initial direction of motion of the mass m. So it means, let's say this mass m will move to an angle theta 2, and this will move at an angle theta 1 with the initial direction of motion of the mass capital M. So then the largest possible value of the ratio m by m will be less than or equal to how much? The largest possible value of the ratio m by m for which the angles theta 1 and theta 2 will be equal is. So if theta 2 and theta 2 are equal, then the largest value of the ratio m by m we have to find out. So here we can apply the conservation of linear momentum of the system. So if their final velocities are v2 and v1, so then I can say, so theta 1 equal to theta 2, I can say, let's say that is equal to theta. This is equal to theta only. So then I can say this will be v1 cos theta, and this will be v2 cos theta. So this way it is v1 cos theta plus v2 cos theta, v2 v1, and then here this is theta, and then this will be v2 sin theta. This will be equal to v1 sin theta, v1 sin theta, and this is mass m. This is mass actually capital M. This is mass capital M, and this is mass small m. So along the y direction also the net momentum will be conserved. And along the x-axis also the net momentum of the system will be conserved. So we can say m into v naught plus m into 0, that will be equal to here mass is m. v1 is the velocity of mass capital M, and v2 is the velocity of mass small m. This will be m v1 cos theta plus m v2 cos theta. So therefore I can say m v naught, that is equal to cos theta into m v1 plus m v2. And also along the y-axis the net momentum should be 0 only. That means m v2 sin theta, that will be equal to m v1 sin theta. M v1 sin theta. So sin theta will cancel. So I can say m by m, that would be equal to v2 by v1. M by m, that will be equal to v2 by v1. So, and there is an elastic, it is an elastic collision also. It's an elastic collision. So there is no loss in kinetic energy. Loss in kinetic energy is not there. So I can say half m v1 half m v2 square plus half m v1 square. So that will be equal to half m into v naught square. Since kinetic energy is conserved, since it is an elastic collision. Elastic collision. So here momentum is also conserved and the kinetic energy is also conserved. So half we can cancel out. We can say mv2 square plus mv1 square, that is equal to mv naught square. So if we divide this by v1 square, so from here we can say mv1 that is equal to mv2. These two are same. So therefore I can say mv1 to mv1 into cos theta, that is equal to mv naught. So m will cancel out. So v naught equal to 2v1 cos theta. So mv2, that is equal to mv1. So mv1 into v2 plus mv1 square, that is equal to mv naught square. So m I can cancel. So v1 square plus v1 v2 equal to v naught square. So from here you can say v1 square plus v1 v2, that is equal to 4v1 square cos square theta. So therefore v1 square. So now if we divide both sides by v1 square, then we'll get 1 plus v2 by v1 equals to 4 cos square theta. Means v2 by v1 will be equal to 4 cos square theta minus 1. So m by m, that will be equal to 4 cos square theta minus 1. So therefore the maximum value we have to find out, the largest value of m by m. So now as we know, cos square theta, its value will be more than or equal to 0 but less than or equal to 1. So therefore 4 cos square theta, that will go from 0 to 4, and therefore 4 cos square theta minus 1, that will be greater than or equal to minus 1 but less than or equal to 3. So therefore, this m by m value, m by m, that will be more than or equal to -1, but less than or equal to 3. But it can't be negative, so it can be more than or equal to 0, but less than or equal to 3. So it means that its maximum value can be 3. So it's the largest possible value of the ratio m by m should be 3. So option C is the correct answer. And here it is told 3 objects A, B, and C are kept in a straight line on a frictionless horizontal surface. The masses of A, B, and C are m, 2m, and 2m respectively. A moves towards B with a speed of 9 meter per second and makes an elastic collision with it. Thereafter, B makes an completely inelastic collision with C. All motions occur along the same straight line. The final speed of C is. So M makes elastic collision with B, which is of mass 2m, and B makes an inelastic collision with uh, C, which is of also of mass 2m. So A moves towards B, initial speed that is 9 meter per second. So initially B is kept at rest. C is also kept at rest only. U2 is 0. U3 is also 0. U1 is equal to 9 meter per second. So therefore I can say M1 U1 plus M2 U2, that is equal to M1 V1 plus M2 V2. Since here momentum is conserved for the collision of A and B, and the kinetic energy is also conserved since it is an elastic collision, or we can use the um, coefficient of restitution. So E will be equal to V2 minus V1 by U1 minus U2. So this will be V2 minus V1 by U1 is U, that is 9 minus 0. So E is equal to 1. So V2 will minus V1, that is equal to 9. This is one of the equations. Now M1 is M into U1, that is 9, plus M2 is also 2M, and U2 is 0, that is equal to M1, that is M into V1, plus M2, that is 2M into V2. So M can cancel. You can say 9 equal to V1 plus 2V2. 9 equal to V1 plus 2V2 plus 2V2. V2 I can say 9 plus V1. So therefore I can say 9 equal to V1 plus 2 into V2. So 2 into 9 plus V1. 2 into 9 plus V1. So therefore 9 will be equal to V1 plus 2, 9 is 18 plus 2V1. So therefore 3V1, that is equal to 9 minus 18, that is equal to minus 9. So V1 will be equal to minus 3. So V1 equal to minus 3. So this mass, this object A will move towards the left with a velocity 3 meter per second, and B will move, V2 will be equal to 9 minus 3, that is equal to 6 meter per second. So the block B, the object B will move towards the right with a velocity 6 meter per second. Then it will make completely inelastic collision with C. So therefore, here also we can say that M2 U2 plus M3 U3, that is equal to M2 V2, no, M2 plus M3 into V. Since it is completely inelastic collision, so V1 will be equal to, so V2 will be equal to V3, or I can say V2 dash will be equal to V3 dash, which is equal to V, suppose. So therefore M2, that is V2 dash, I'm saying the velocity after inelastic the velocity of block B after inelastic collision with C, and V2 and V2 dash and V3 dash, which is the final velocity after of C after inelastic collision with B. So they will be same, since why they will stick to each other. They will stick, since why it is told that it is a completely inelastic collision. Completely inelastic collision means they will stick to each other. So V, final speed of C, that is V only. So V has been asked. So V will be equal to M2 U2. So here U2 is actually V2 and V3. So V3 is 0 only, since initially the block C was at rest, and V2 that is equal to this 6 meter per second. Therefore V will be equal to M2, that is 2m, into V2, that is 6, plus M3, that is also 2m, into 0 by M2, so 2m plus 2m. So this will be V will be equal to 6 to the 12, 12m by 4m. So 4 3 is 12. V will be equal to 3 meter per second. So it means that the block C will move towards the right with a final velocity 3 meter per second. So option D is the correct answer. Then here it is told 2 billiard balls of equal mass 30 kg strike a rigid wall with same speed of 108 km per hour as shown, but at different angles. If the balls get reflected with the same speed, then the ratio of the magnitude of impulses imparted to ball A and ball B by the wall along the x direction is. Okay, so here you have to find out that. So in the case A, so here the impulse that is imparted, the case 1, we can call it as J1 or I1, suppose, impulse according to the ball A, IA. So that will be equal to change in momentum of the ball A. So that will be equal to mu, since why it is initially moving like this, it is initial velocity u and final speed is also u, but in the opposite direction. And here also the initial speed is u, here also the final speed is u, but here this at this angle theta is 45 degree, this will be u cos theta, and this also this way it will be u cos theta only. This will be u sin theta. U sin theta component will remain constant, it will not change. So in the part A, the impulse in part A, that is equal to mu minus of minus mu. So that will be equal to 2 mu. So there is 2 m is 30 gram, means 0.03 kg, and u is 108 kilometer per hour. So I can say it will be 108 into 5 by 18 meter per second. So this will be 9 to the 18, 9 ones 9 to the 18, 2 6 are 12. So 6 is 30 meter per second. So into 30. So this will be the 6 0.06 into 30. So this will be 0.6 into 3. That is 3 6 are 1.8 kg meter per second. So it is, or I can say 1.8 Newton second. So it is the impulse in part A. And then impulse in part B, that will be equal to, so the initial momentum, that is mu cos theta, minus, this will be minus mu cos theta, minus mu cos theta. This will be equal to 2 mu cos theta. So therefore, ratio of the magnitude of impulses. So therefore, I have to find IA is to IB. Ratio of the magnitudes of impulses to ball A and ball B. So IA is to IB. So IA is 2 mu is to IB is 2 mu cos theta. So 2 mu will cancel. So it is 1 is to cos theta. And cos theta, as you know, cos 45 degree, that is equal to 1 by root 2. So therefore, it will be 1 is to 1 by root 2. So, or I can say it is root 2 is to 1. Or I can say 1.4414 approximately is to 1. So root 2 is to 1 is the required ratio of the magnitudes of impulses imparted to ball A and ball B by the wall along the x axis. Then here it is told a bullet of mass 4 kg is fired from a gun. There is a gun. So the mass of the gun, capital M, is 4 kg and mass of the bullet is 4 gram, that is 0.004 kg. If the bullet moves with the muzzle speed u, that is 50 meter per second, I can say it is v1, the impulse imparted to the gun, and the velocity of recoil of the gun, is how much that you would find. So here the impulse imparted to the gun will be same as the impulse imparted to the uh, to the bullet also. Means their magnitude will be same. The magnitude of the impulse imparted to the gun will be same as the magnitude of the impulse imparted to the bullet also. Since why, according to the Newton's third law, action force and re reaction forces are equal in magnitude, but they are opposite in their direction only. So the magnitude of impulse imparted to the gun, that you have to find out. So that will be equal to the magnitude of impulse imparted to the bullet, that will be equal to mv1 minus m into 0. Since why, initially the gun and the bullet were at rest only. Initially the system was at rest. Initially system is at rest only. So m, that is 0.004 into v1, that is 50. This will be equal to 0.04 into 5. So this will be 5 fours 20. So 0.2 kg meter per second. And the recoil velocity of the gun we have to find out. So we can say m into velocity of recoil, that will be same as the impulse of the, so the gun will get recoiled with a velocity vr. Vr only we have to find. That will be same as m into v1. So vr, that will be equal to m by m into v1. So m, mass of the bullet, that is 0.04 by mass of the gun, that is 4 kg, into v1, that is 50. So this much meter per second. So that will be 0.001 into 50. So that will be 0.05 meter per second. So option C is the correct answer. And here it is told, if the kinetic energy of a moving body becomes 4 times of its initial kinetic energy, if the final kinetic energy is 4 times of its initial kinetic energy, then the percentage change in its momentum will be. So here the initial momentum, let's say it is p, then the final so the final momentum, that is equal to root over 2m into kinetic energy, final kinetic energy, and initial momentum, that is equal to root over 2m into initial kinetic energy. Since p square by 2m is kinetic energy, so p square, I can say it is 2m into kinetic energy. So p is equal to root over 2m kinetic energy. where m is the mass of the body. So this will come 2m into 4 times initial kinetic energy. So root over 4 is 2. So it is 2 into root over 2m initial kinetic energy. So it is 2 times of the initial momentum. So final momentum is 2 times of the initial momentum. So the percentage change in the momentum we have to find. So the percentage change in the momentum, that will be equal to final momentum minus initial momentum by initial momentum into 100%. So final momentum is 2 p initial minus p initial by p initial into 100. So p initial by p initial, that is 1 into 100. So that is 100%. So 100% change in the momentum will take place. So option A is the correct answer. So here it is told an object of mass m1 collides with another object of mass m2 which is at rest. So u2 is 0. So its initial velocity is u1. After the collision, the objects move with equal speeds in opposite directions. So after collision, they move with opposite directions with equal speeds, m1 and m2. The ratio of the masses m2 is to m1. So m2 is to m1 we have to find out. So after collision, this will happen. So here we have to apply the principle of conservation of linear momentum of the system. So initial momentum of the system will be equal to the final momentum of the system, since the momentum of the system will remain conserved. So the initial momentum of the system, that will be equal to m1 u1 plus m2 u2, that is equal to m1 v1 plus m2 v2. So if we take the direction towards right as positive, then the direction towards left will be obviously negative. So therefore I will say m1 u1 plus m2 into 0, that is equal to m1 into minus v plus m2 into v. So therefore I can say this will v into m2 minus m1, that is equal to m1 u1. Equal speeds in opposite directions. So v will be equal to m1 u1 by m2 minus m1. They're moving in opposite directions. Okay. They are moving in opposite. So it is not a head-on collision. This is wrong actually. It can't be a head-on collision. The collision can happen at some angle also. So let's say m2 move at an angle theta, then m1 will move at an angle 180 minus theta. Same with equal and opposite velocity v. So here I can say that -180 minus theta, then this will be theta. Then we can say this will be V, this will be M1V. So this is happening after the collision. This P2 will be M2V cos theta here. No, this will be M2V sin theta. This will be M2V cos theta. And this way, this is 180 minus theta. So this will be theta. 180 minus theta, then this will be theta. So this will be M1V. This is V. So this is M1V cos theta. This way it will be theta. Okay, M1V sin theta. So this will be M1V sin theta. M2V sin theta. Okay. So M1V sin theta, that will be equal to M2V sin theta. Also, we can say that M2V cos theta minus M1V cos theta, the final one, that will be equal to M1 U1. You can say V cos theta into M1 minus M2, sorry, M2 minus M1, that is equal to M1 U1. So V cos theta, that is equal to M1 U1 by M2 minus M1. Then sin theta I can cancel, and V also I can cancel. So here it is coming M1 equal to M2. So M1 equal to M2 means M2 by M2 is to M1, that is equal to 1 is to 1. M2 by M1 is equal to 1. So M2 by M1 is 1 is to 1. So option A is the correct answer.